the experiment number 7 is Wayne Bridge oscillator using OPAMP. The aim is to design a Wayne Bridge oscillator using OPAMP for a given frequency of 1 kHz. The theory is an oscillator is a circuit that produces periodic electric signals such as sine wave or square wave. The application of oscillator includes sine wave generator, local oscillator for signals, receivers, etc. An oscillator consists of an amplifier and a feedback network. So this is an active device. OP-amp is used as an amplifier. Passive components such as R2C or L2C combinations are used as feedback network. To start the oscillation with the constant amplitude, positive feedback is not the only sufficient condition. Oscillator circuit must satisfy the following two conditions known as Barkhousens condition. That are magnitude of the loop again is 1 in, and second one is phase shift around the loop must be 360 or 0 degree. So here we can see the basic block diagram. When Wayne Bridge oscillator is an audio frequency sine wave oscillator of high stability and simplicity, the feedback signal in the circuit is connected to the non-inverting input terminal, so the op-amp is working as a non-inverting amplifier. Therefore, the feedback network may not provide any phase shift. The circuit can be viewed as the Weinberg filter series combination of R1 and C1 in one and parallel combination of R2 and C2 in the adjoining amp. The series and parallel combination of RC network from a loop lag circuit at high frequency, the resistance of capacitor C1 and C2 approaches zero. This cause C1 and C2 appears short. Here the capacitor C2 shows the resistor R2 and the output voltage V0 will be zero since output is taken across R1 R2 combination. So at a high frequency circuit acts as a lag circuit. So at the low frequency, both capacitor act as open because capacitor offers very high reactance. Again, output voltage will be zero because the input signal is low across the R1 and C1 combination. Here the circuit acts like lead circuit. But at one particular frequency between two extremes, the output voltage resets to the maximum value at this frequency only. Resistance value become equal to the capacity reactance and gives the maximum output. Hence, this frequency is known as the oscillating frequency. Here we can see the circuit diagram of Weinberg oscillator. This is the circuit diagram. Here we can see one resistor and there is capacitor uh, in a series connection and one resistor and another capacitor in parallel connection. Uh, Two resistors connected along. So this is the circuit diagram for Weinberg oscillator. So when we come to the design part, this is the equation for the design part. So this is a simplified design that is S is equal to 1 by 2 pi root of R1 C1 up to C2. So here we can see the output graph which we are obtaining, that is F is equal to 1 kilohertz. The result is a Weinberg oscillator was designed and set up for a frequency of 1 kilohertz and the output waveform is outside.